Okay. So what we've got today is fractions, addition and subtraction. Okay, they're very different methods for adding and subtracting fractions, but I'm going to show you the method I think is the easiest, and we'll take it from there. Okay, so if I represent the process with letters, so if I have a fraction, a over b, can be proper or improper. Remember, we never solve with mixed fractions. We convert them to improper fractions before we use them. We want a over b plus c over d, and what we're supposed to do is multiply a and d, put that in a bracket, take the sign, multiply across b and c, and at the bottom multiply b and d. Okay, now if it was for subtraction, we would multiply a and d first again. That would go on the left, bracket that up, take the sign, subtract c times b, or b times c, same thing, over b times d at the bottom. Okay, if we keep that in mind, the process should be very straightforward. Okay, we'll go into a couple of questions now. So, I said to myself, 1 over 2 plus 1 over 3. If I go through that process, it would be 1 times 3 plus 2 times 1. Make sure you notice where I'm getting all the numbers from. And then finally 2 times 3 to go under. That leads to 1 times 3, that would be 3, plus 2 times 1, that would be 2, all over 2 times 3, that would be 6. Now we'll end up as 3 plus 2, 5, over 6. Okay. Now, once again, 2 over 3 plus 5 over 6. Okay. First things first. 2 times 6, so in the same positions as a and d. The sign is plus, and then b times c, so 3 times 5. And then 3 times 6 at the bottom. So 2 times 6, that's 12, plus 3 times 5, that's 15, and then 3 times 6 at the bottom, that's 18. So our answer becomes 27 over 18. Now with this method, at the end, it's important to check if it can be simplified. Okay? 5 over 6 couldn't be simplified. No common factors between the top and the bottom. For 27 and 18, there are common factors between the top and the bottom. So we have to check that. So 27, if I break that down, that's 3 times 3 times 3. You know how to do that by now. 18 as a product of prime factors, that would be 2 times 3 times 3. So there's a 3 at the top and a 3 at the bottom. Cancel that out for 1 and 1. There's another 3 at the top and at the bottom. Cancel that out for 1 and 1. So we end up with 27 over 18 simplified. That's just 3 over 2. Okay? Once again, have a different example. 7 over 8 plus 5 over 3. Okay? Same process. A times D, same position, so 7 times 3. Plus across 8 times 5 and then below will just be along the bottom 8 times 3. Okay, 7 times 3, 21, plus 8 times 5, that's 40. Now 8 times 3, that's 24. So at the end of this all, we have 61 over 24. Now, I do not believe there are any common factors between 61 and 24, so there's no simplifying to be done. That's the final answer. Okay? Now, another example involving a whole number. So, here we have 2 plus 3 over 5. Now remember, a whole number is also a fraction. So I can write that as 2 over 1 plus 3 over 5. And I repeat the same process. Across, here first, 2 times 5. Plus is the sign. And across, 1 times 3. And now along the bottom, 1 and 5, so 1 times 5. So 2 times 5, that's 10. Plus 1 times 3, that's 3. 1 times 5 is 5. So we have 13 over 5. No common factors between 13 and 5. They're both prime numbers anyway, so we stop there. No simplification to be done. Okay? Okay. Now, once again, I can repeat the same process. Seven over 3 plus 2. Okay. Do this again. Remember that a whole number is also a fraction. So across 7 times 1, the sign in the middle is plus. Across again, 2 times 3, or 3 times 2. And at the bottom, 3 times 1. So 7 times 1 is 7. 3 times 2 is 6. All over 3 times 1 being 3. Okay, that's 13 over 3. Another prime number at the top and bottom. So no common factors between those two. So that's our final answer. We can't simplify that any further. So just 13 over 3. Okay? Now, if we're dealing with the case of mixed fractions, okay, all we have to do is convert each one to an improper fraction. So 2 1 over 2, that would be the bottom number 2 times the whole number 2 plus the top number of the proper fraction, that's 1, and the bottom number never changes, so that's just 2 again. That would result in 2 times 2 plus 1, that's 4 plus 1, so that's 5 over 2. Okay? And in the case of 1 3 over 5, it would be the bottom number, 5, times the whole number, which is 1, plus the top number of the proper fraction, that's 3, all over 5. So if we complete that, that's 5 times 1, which is 5, plus 3, that's 8, all over the same bottom number, 5. So when we want to solve this problem, we use the improper versions. Okay, so 5 over 2 plus 8 over 5. We go across, so that's 5 times 5 plus, we go across again, that's 2 times 8, and for the bottom, we go along, and that's 2 times 5. So 5 times 5 is 25, plus 2 times 8, 16, over 2 times 5, which is 10, and that results in 41 over 10. Looking at that, there are no common factors between the top and the bottom. Okay, so there's no simplification necessary, and that's where we stop. And so the answer is 41 over 10. Okay, convert to improper fractions, and then carry out the same addition process. Okay, now for subtraction, would the same process apply? Absolutely, only the sign changes. Okay, so I go across 2 and 2, so that's 2 times 2. The sign in between is a minus sign. And then I go across 3 times 1. All over, along 3 times 2. So 2 times 2 is 4, minus 3 times 1 is 3, all over 3 times 2, which is 6. So I end up with 4 minus 3, 1 over 6. Okay? Another example, we have 7 over 8 minus 4 over 5. We go across again, 7 to 5. The sign in the middle is a minus. We go 8 to 4, so 8 times 4. And at the bottom we have a long 8 times 5. 7 times 5, 35, minus 8 times 4, that's 32. At the bottom, 8 times 5, that's 40. So 35 minus 32, that's 3. At the bottom, still 40. Now, there's nothing to reduce there. No common factors between the top and the bottom. So, that's our final answer, 3 over 40. Okay? Now, in a case where we have whole numbers, does the process change? No. Because remember, a whole number is also a fraction, so we write that as 4 over 1 minus 15 over 4, and we go across. 4 times 4, minus, that's the sign there, and we go across. 1 times 15, all over, going along at the bottom, 1 times 4. Okay, so that's 16, minus 1 times 15, that's just 15, over 1 times 4, that's just 4, and so we end up with 1 over 4. Okay? Now, once again, what happens if we have a situation where we have mixed fractions? Remember, we don't like to do things as mixed fractions, so we convert to improper fractions. For 2 1 over 2, it's bottom number times whole number plus top number of proper fraction, which is 1, all over bottom number. Okay? 2 times 2 is 4, plus 1, 5. So that becomes 5 over 2, and for 1 3 over 5, bottom number remains the same, that's just 5. The top number for the conversion, we take bottom number, we multiply by the whole number 1, so that's 5 times 1. Box that up, and then we add the top number of the proper fraction, 3. So 5 times 1, that's 5, plus 3, that's 8 over 5. So those are the fractions we now use. Okay? So I then say 5 over 2 instead of 2.5 minus instead of 1/3/5, I say 8/5. And so we do the same process. We go across 5 times 5. Sign in the middle is a minus, so we have a minus. And then we go 2 times 8. All over, we go along, 2 times 5. So 5 times 5 is 25. Minus 2 times 8, so that's 16. All over 2 times 5, which is 10. Now, 25 minus 16, that's a 9 over 10. Okay, there's no common factors between the top number and the bottom number, so that's where our final answer is, 9 over 10. Okay, that should be straightforward. Practice a couple of questions and you'll be fine. Okay, thank you very much. You've been listening to the Math Done, and until next time.